Hello and welcome back. In the last video, we briefly discussed about the history and genesis of generative AI. And in this video, we are going to discuss one of the most critical element of any generative AI application, which is large language models. Short form is LLM. So let's see that. So what is a large language model? Specifically, what is a language model first? Let's look at that. So language model, nothing but that official definition is which computes the probability distribution of all the words in a vocab over a sequence of words. So mathematically, this is how it's given. However, as you might be thinking, what this even means exactly. So in plain English, it simply means that given a sequence of words, what should be the next word? And this is the job of language model, as simple as that. So given a fragment of sentence, it tries to figure out what comes next, which word comes next. For example, if I have a sentence called, say, I am reading a blank, then what do you think? What will be the next? So based on our knowledge or life so far, we know that most probable word will be book. You can read other things like newspaper, you can read electronic newspaper, whatever. But we know that the book is the next, which maybe the most highly likely word that will come, right? And why do we think that? Because we have seen so much of example, and this sentence mostly occurs with book, right? So that's the case. So there could be a number of probability. Like next word could be a car, a tail, doesn't make sense. Book, a computer, right? So what language models are doing is it has a vocab, that means all the known English words, most of it, and based on the given stream of words, it tries to calculate the probability of all the words available in its vocab and gives a number, probability number. So for car, it is giving 0.13, for tail 11, book 0.99, and computer 212. And it logically it selects the word with the highest probability, which is book, and that's how it completes this sentence, right? And this is what language models do exactly. So its training just brings the capability into the model to predict the next probable word with as much accuracy as possible. And we have seen this example in day-to-day life. Like for example, if you go in your search engine, like let's say Google or Bing, you type a word, then it will automatically start giving you suggestion, right? What will come next? Why? Because the lot of people have been searching for similar sentences. It knows that okay, these three words combination occur with this fourth word, right? So let me give you an example, like how that looks. So I am in Bing, right? So you can use any search engine. So let's say I start searching for US and I type ST. Okay, just 1 2 3 4 5 letters. Now it gives me suggestion that okay, these are the possible. The first one, which is the highest probability one, is the US stock market, and this is exactly what I was looking for. All right. So for example, let's try I am reading a, see, highest probability is the book. So this is nothing but example of language model. Similarly, you must have seen while typing in your messaging app on your mobile, if you type, then it keeps suggesting the next word. And this is the language model, nothing more than that. So it's just a machine which has been trained to predict the next word. That's a language model that we have to keep in mind. Okay, so let's go back. So all right. So now question is, since we are not talking about the language model, we are talking about large language model. So what does it mean? It's obvious. The language model that's been trained on a huge amount of text data, hence it is large. You might be thinking huge means How large? So just to give example, even though official figures are never released by the companies, GPT-4 model was trained on, it is kind of not reported number, but mostly it's educated guess. It's trained on 10 trillion words, and these words came from internet, soft copy of all the books available, research paper, everything text based. That's how large it is. So what does it mean? How does it help? So it helps because it has seen so many examples of text. For example, as a human being, if I read more and more and more books, let's say fiction book, and if I pick up another fiction book, if I read few pages, probably I'll be able to guess, and with a decent amount of probability, I'll be able to guess what's happening next, what's coming on next. Why? Because I've gained that much experience reading so many example. It is same as that. It has seen so many example of text, combination of words, that it knows what comes next. So mathematically, it doesn't, basically it doesn't know, but mathematically what it's doing, as in the previous slide we saw, it calculates the probability of next word based on the previous word. So it's kind of mathematically, it's a conditional probability calculation. Given the sequence of words, what is the probability of this word? And this word means all the words available in English language, most of it, not all. Yeah. And then it selects from the list of words which has largest probability. That's what it's doing. So for example, when we ask a question to LLM, let's say ChatGPT, then based on the words in question, it predicts next word and the next and so on. How it can do that? Again, it has seen a combination of these words already available in the text corpora on which it has been trained, and that's how it can do that. But this also goes wrong at times because it doesn't know the answer. It doesn't understand our question at all. It mathematically, it's trying to calculate the probability. So sometimes it can go horribly wrong, especially for the question which is very not very frequently asked on in day-to-day life. It might not have seen that many examples of that, so it will go horribly wrong in that case. And that's why you see and you say, this is very strange, why is responding like that. So this is the reason why. So this thing already I have mentioned. How large? So GPT-4 is estimated to be 10 trillion words it has been trained on, and based on its training corpora, it acquires that much of knowledge. Now what this knowledge means, so model is nothing but it's a humongous mathematical function, right? And within this function, as part of its training, it has figured out some numbers. So based on training, it has acquired knowledge and stored as a floating point number. And these numbers are called parameters or weights. So larger the model is, larger its weights it, and larger its capability, or better it's capable of doing the task it's assigned. Okay, so here is a kind of a picture where it's gives you how we have progressed in terms of this large language model. So GPT-1, which we saw in video 1, that came I think around 2018 after the release of Transformers paper, and it has 117 million parameters. That means floating point numbers. After training, it has calculated these 117 million numbers and stored. So it is stored within the model itself. So consider this as our brain, where I don't know, maybe how many billions of neurons are there, and they are specifically connected to each other, right? And that's how we gain knowledge, because our neurons forms new connection when we learn new things. It is similar. As part of training, it has calculated these numbers and it's stored as a floating point number. So in GPT-1 case, 117 million. So you can read through all this, how it has progressed, and it is said to be that GPT-4 has 1.76 trillion parameters, right? You can think these models as a large machines, let's say oven in our kitchen, and in most sophisticated ovens you might have seen few dials which we move for, let's say temperature, for fan speed, and I don't know, there might be some other knobs to control a lot of aspect of the oven, and based on that, depending upon the dish we want to prepare, we adjust that, right? So these 1.76 trillion weights are, you can consider them as knobs in the oven, which is our large language model. And as part of training, model has figured out which knob has to be at which level, and that is fixed as part of training. So that knowledge it has acquired. So this is how, and that's why if you think about it, language models are doing nothing more than predicting next word. Large language model is same, it's language model, it knows nothing else more than predicting next word. And think about it, just doing that, it can do some mind-blowing things, like it can write articles, it can write emails, it can prepare resumes, it can write code, right? And why it is possible? It is possible because the humongous amount of data has been trained on, and the amount of knowledge that is acquired, right? So now let's look at the type of LLMs. So there are mainly two types. One is open source LLM. Open source means there is parameters, weights, and its code is freely available to public, and anybody can download and change it or use it. And there are examples. So Meta was the pioneer in this case, and they came up with the Llama, and then Llama 2, and then now Llama 3. They are open source models, and they are getting better and better. Alibaba has a very powerful model called Qwen. A recent kid on the block is DeepSeek. Everybody must have heard about it. Some researcher in China, they managed to train model using very cheap domestic hardware, so without using expensive GPUs. Now DeepSeek is not a model which has been designed ground up. It is based on Llama. So Llama has been specifically trained or fine-tuned to create this DeepSeek model, and we'll be experimenting with Llama and DeepSeek both in our tutorial when we'll be doing projects. Microsoft they have many models. So one of them is Phi, which is a compact, very small model, and it loads a very fast, response very fast, but its knowledge is very limited. This is also open source. Now these are the frontier models, also called closed source LLMs. Closed source means source and its number of parameters, it's not known to public. It is proprietary and held by the companies or organization creating them. So OpenAI has GPT series of models. So latest one is, I think, GPT-o3, which they have, the frontier model. Anthropic has various series of model. Their state-of-the-art model is called Claude. Google has Gemini, and recently xAI has released Grok 3 model, which is closed source. And what's interesting is when they release Grok 1 and Grok 2, these models are open source, but Grok 3 is probably closed source, and possibly their model is that once they phase out a model and release a new one, the previous models are made open source. That's how it's going to be. So latest is Grok 3. Okay, so there are two types of models. What are the strengths and weaknesses of frontier models? So mostly, if you are thinking about building some complex and commercial applications, then frontier models are the models we should be using compared to open source. Even though open source models are getting better and better every day, but since they are free and the budget is limited, so their training data and training time is also limited, so their capability is limited. So there is always a trade-off. So let's talk about the frontier models' strengths and weaknesses. So in terms of its strength, obviously they're very good at synthesizing information. So if you give a large block of text and ask question on this, or ask them to summarize it or highlight certain points, then they are very good at going through the text and synthesize the information and present it to you so that you can understand easily. Then other way around, they can enrich details from skeletons. For example, you can give few sentences like, I am working on a presentation and these are the high level points. Can you give me the content of the presentation? And you provide more context about the domain you're working on. And obviously they are going to do a fantastic job if you have used any frontier model and provide a very good material for your presentation. One thing that separates frontier models from open source models is reasoning capability. Reasoning capability means they can look through a problem, they can think through, and they can break the problem step by step. They can generate a plan just like a human being. Like if you give me a complex mathematical problem which has 5 steps, then first thing I'm going to do is I'm going to think through, break the problem in 5 pieces, and then I'll prepare a plan that how I'm going to attack it. The same thing with these models. And this is where open source models lack, because possibly it is the amount of data they are trained in. And you will see this difference we are going to see when we are going to do projects. Like if you use a frontier model, then what result you are getting, and if you are using open source model, then what result you are getting. There is a difference which we can clearly notice. Obviously they are very good at coding, so they have been trained on all the codes available in GitHub and wherever, all the repositories available, and they are very good at generating code. If you give a buggy code, then they will tell you, okay, this is wrong. So they are excellent on that. Now, what are the weaknesses of these models? So first is still the models are being trained on a generic corpus of words, but there are specific models which are nowadays people are taking it and fine-tuning a specific domain. But in general, the frontier models which are available now from this bigger corporation is still, they are not specialist on any domain. Like for example, somebody who has done a PhD in physics will be more knowledgeable compared to any of these models, frontier models. If you ask a question, then you're going to get more accurate answer from the specialist rather than these models. Another domain could be the medical domain, where obviously there is effort and research is happening on that, but still they're not as good as that you just dump your doctor and use the model. We are not there yet. Recent events, obviously, as we discussed, that models are doing nothing but predicting next word based on its knowledge gathered, which is floating point number that it has stored as its weights, right? So that knowledge is fixed. Okay, so it cannot answer questions or cannot reason through anything which happened after its cutoff training. And if you ask it, sometimes it might say I don't know. Sometimes it will just give you a weird answer. Okay, so recent events, obviously, because based on the knowledge beyond its knowledge capability, it's not going to provide. There are techniques to enhance that we'll see in the series in future videos, but in general they are not very good at this point. Then hallucination. This is again, if you let model run wild, do not provide much of the context or anything. If you ask a question, it is going to give you some answers which is unrealistic and not accurate. So it's very easy for this model to, because they have so much data, so they can generate some output which looks real and accurate, but actually it is not. So that's also a danger sometimes. So it's a good idea to fact check what they are producing. So how do we access these models, LLM? So there are various methods. One is the very most common one, which we use every day, is chat interface. So you just go to the ChatGPT website or Gemini website and you just open it and start using it. And if you have taken a subscription, then probably you'll have access to a better model. Otherwise, I think they have a free tier as well. So this is everybody who is using AI, they know that chat interface is the most common one to use. And this is not the subject of this series, because we are not going to use chat interface, because we are here to build the application. So we want to connect to model programmatically. So in order to do that, every model provider, they open up their API for their models, and then through our code we make API calls to connect to these models. Then models can be hosted by the provider itself, like in a chat GPT. If you go to chat interface, you are basically connecting to OpenAI hosted chat model, and using API also we can connect to programmatically to provider hosted models. Another option which companies who are concerned about their data security and privacy issues, they host the copy of models in cloud. So for example, in Azure, they provide facility to host OpenAI models, and this is one of the method that I'm going to use in the tutorial. But regardless of where it is hosted, the API doesn't change, so it remains same. So everything is behind the scene. It's something to do with the data privacy, right? So it doesn't matter whether you are using this one or that one. Now, in terms of connecting, there are two methods how you can use the API. One is the direct raw API. So in that case, you have to call the model using the raw API and provide the data in their prescribed format, which I'm going to show briefly, like how OpenAI at least expect the message to be sent to them. Another method that we are going to use is through a framework. So we are going to use LangChain. There is another popular framework is Instructor. So what these frameworks are doing is they are abstracting away the model specific APIs. So they provide a single unified interface to us through which we can connect to model. And we do not need to worry about whether behind the scene, whether it is OpenAI, Anthropic, or Google, or Microsoft, whoever it is, because their API might differ here and there, and that difference is taken care by the framework. So we are not too concerned about that. Okay. Another last method, third method, is using the direct interface, and it is applicable only to the open source model. And Hugging Face is a company that hosts a lot of open source model developed by small companies or people, researchers, and we can download this model and experiment with these models or build application with these model at a very granular level. So we have control which is not possible here because we are limited by the API that the provider offers. In this case, we have access to the model weights, the model itself, right? Even the tokenizer. So we'll be doing this as well in future videos. And Hugging Face provide a transformer library for this, doing this. Now let me just quickly show when we are calling API, raw API, what kind of message formats they expect, at least OpenAI. So I'm at this site. You can just search OpenAI API message format and you'll end up, you'll find few links, you'll end up here in quick start. If you go, here is the one example. So basically you have to download or pip install OpenAI provided package, and then using this package you have, this is how they, in Python, this is how they prescribe you should be calling their model. That means if you're passing a message like this one, then this is the format they expect. It has to be a dictionary with two keys. One is the role, another is the content. Content obviously is your message. Role is if we are sending message to the model, it will be user. This will be continuous to and fro messages. Every time I ask question, it will be user. There is another type of message where role is a system. So that system role is to be specified generally once. You can specify more than once, but generally system is to tell model that how it should behave, setting up its persona. So say restricting it. So let's say you want model to be expert in soccer only and you should not answer any other question. So in system message where you specify role equal to system, you can say that that you are expert in a game of soccer and you should only answer question pertaining to soccer. If anybody asks anything else, just say you don't know. So that's kind of setting up the model behavior. And then from there on, you send message using the user role. Now, when you're sending the message to a model is going to respond back, and it is going to respond in a similar kind of dictionary when you consume using HTTP, when you take the responses. Then the role that is will be on the incoming message to you will be assistant. So that's how we differentiate. So user we are sending, assistant model is sending. So this is the format they expect, but as I said, we do not need to worry about this format or the format defined by, because this is OpenAI, so defined by other providers, because we are going to use a framework called LangChain. So LangChain takes care of this straight away. So what we have to learn is just how the LangChain wants us to send and receive messages. That we'll see in future video when we go through LangChain intro. So this is just for FYI. This is something we do not need to understand fully. Okay, so let's go back. All right. So as we said that model expect the messages to be sent in certain format. So obviously this whole message is not dumped into the model. Model consumes it piece by piece. So what that piece is, what's the smallest unit of input and how it responds. So smallest unit of input, it may appear as words, but actually it is not words. In latest models, it's called tokens. If we look at the early models, that is prior to, I think, when 2022, then the models were trained on letters to predict the next letters, not the next word. So model vocab is obviously very, very small for English language, 26 letters and 10 numbers. That's it, right? But the downside of this is model loses the context or the semantic meaning of the words. If you break a word in single word in letters, then looking at the letters is very difficult to comprehend what's going on, right? So obviously the next logical step was to feed the model with the words so that it understand. The problem this approach poses is your vocab becomes very large. So the number of words that the model needs to know is all the words in English language, all real words, stem words, and derivatives, right? So researchers came with a workaround, and which is something in between these two. And instead of feeding the word itself, every word, they define something called token. So token is very similar to word, but not exactly. And that we'll see shortly what do I mean. So token means all the known words to the model. So that reduces the size of vocab. So it doesn't store everything in English language, but very common words it do stores, right? And the uncommon words is unknown to the model. So reducing the vocab size. And these are the tokens. So OpenAI provides us a tokenizer website, which we can check like what it means. So here you can experiment with like how your sentences are broken down into tokens. So if this is a sentence, then there are 8 words in this sentence, but it's saying 10 tokens. It's saying 10 because it has broken down this and this, labyrinthine and cities, into 2. So you see, so it knows about labyrinth, but it doesn't know about labyrinthine. So it considers labyrinth as one word, one token, sorry, and ein is another token for the model. All right. So if you take a proper sentence which has all the very common words, then you'll see token and. So there are 9 words and there are 9 tokens. So there is no broken words in here because these are very common words. So it knows about it. Roughly, I think 0.75 words make up one token. All right. That's very rough estimate. So they are similar but not same. Let's go back. So now from the token we come to the topic of context window. What is a context window? Context window is the maximum number of token a model can consume. So in one shot, how many tokens it can take? It has a limit. It has a limit because inside the model, given that, as we talked about in earlier slide, it's a very huge function, mathematical function, which take input numbers as inputs, because all the words or tokens we are feeding, ultimately they're converted into numbers, and that is fed to a model. And the feeding mechanism is by using a matrix of certain size, which is fed to the model. Now this matrix size is fixed depending upon the model architecture, and that's why it's context window which is said is fixed. So context is something which model can consume in one go, right? So what really context include? Obviously it includes the initial question you asked. Also it includes what response the model gave, and any subsequent question its answer, the whole thing, right? So consider this as talking to someone. So you are discussing about a topic with your friend. So obviously you're not only concerned about the immediate question and response. So if you had asked previous question, or he had asked previous question and you responded back, then your next question or answer will depend upon what you talked just now or previously. So the whole context really matters, right? So in a similar way, model context includes initial input, initial output, and subsequent input and output as a context, so that it can provide you meaningful answers. So you must have noticed this already in chat platform. If you go and ask question, if you, let's say my name is XYZ, you ask something else, and after 10 question you ask what is my name, it will be able to answer you because it remembers the whole context. But if the context becomes if your answer question session ran longer and previous question fell out of the context, then it won't be able to answer. And this used to happen in earlier models when the context window was very small, right? But now the context windows are pretty large. That I'm going to show you how large it is next. So that problem is not there, but just to understand that model needs to know about the context like human being to answer you meaningfully. And this is, again, the context is just like a memory, right? So you remember what we talked about just now, and then based on that you answer. So outside the context window, obviously model doesn't remember anything. Now, one thing I want to mention is this context window doesn't mean that LLMs itself or the model itself is storing it. LLM doesn't store anything. In fact, it doesn't know anything. You ask a question, it responds, then it forgets about one single response. Okay, these are just a stateless function. So you give an input, it produces output, and that's it. It forgets. So next question you ask, it doesn't have any memory of what was the previous question and what is responded. Then how does it work? So the chat interface itself, and you will see that when we are building the application, the framework itself will ensure that, and the way we are going to send questions to the model will ensure that we are providing the full context every time to the model. So initially one question, it sends the answer. Now this answer is also attached in the question, and when you're asking next question, previous answer, and next question will go as a context to the model. So every time it gets the full picture. Important thing to remember, it doesn't store anything. It's totally stateless. Okay. So we'll look at how large the context. So first, let's talk about the API pricing. Obviously, when you use the chat interface, then you can use the free tier, and a lot of provider, they offer paid tier as well for latest model access, right? So, and that's mostly monthly basis. So you are charged monthly $20 or $30, whatever the charges are. But in case of API, you are charged based on per call. So per API, it counts how many tokens you have used. Again, the tokens is input and output both, and both are being charged. So that's an important thing to remember. So in order to use API, which we are going to use when we are building the projects, you should have an account with the provider's model you are using. For example, if you are using OpenAI GPT models, then you should have the OpenAI account, and you should have obtained an API key and sign up process is pretty simple. If you just go to any search engine, ask OpenAI API sign up, it will give you a page. You provide your email address, your details, and then you have to provide your credit card details, and it will store, and then it will give you, and you will be able to generate something called API key through which you can access the model. Okay. Now let's look at the context window. Just now we talked about, because context window is number of tokens it can consume, which is very much related with the pricing of the API calls, right? So let's look at that. So there is a company called LLM AI, and they have very nice interface where they compare and keep track of how the model war is going on and which model is doing better on various measurements. They maintain a leaderboard, and they also maintain and provides up-to-date information about the pricing. So let's look at that. Let's go to, so I have opened the LLM AI leaderboard, and this is the leaderboard, very nicely depicted leaderboards amongst the latest models, but you can check them out. Interesting to see, but right now we are interested in something which is at the bottom. So we are interested in this. Okay, so context window and the cost. First column is context window, which model has how large context. Now in our case, I'll be using OpenAI. Where is it? Yeah, I'll be using this one, and this is the I think the cheapest and capable model. So O4 mini, and it has context window of 200,000 tokens. Okay, so 200,000 tokens, if you convert into words, it will come to be 150,000 words. If you convert into pages of text, then it's 300 pages. Now 300 pages is a kind of a decent sized book, so you can send this whole book of 300 pages in one shot, and you can ask question about it. So this is pretty huge context window. And if you see, there's a lot of models here, million and 10 million context window. That's, it's pretty large. So this is never going to be a limitation how much you can send, but obviously there will be limit how much you want to spend, because you will be charged per based on the tokens. So this is O mini charges. So this is input token charges, $1.1, and output token charges, both are counted, is 4.4. So output is more expensive. Now you must be thinking these are very expensive, but actually it's not. If you look at it, it's per million tokens. Okay, so $1.1 per million. Okay, so we are going to use frontier models for our lot of work in the projects, and I encourage you to sign up for one of the models, preferably OpenAI, and it's not that expensive, to be honest. Maybe $5-10 will be more than sufficient for the entire series, because it's not that expensive. But in case you do not want to spend any money, then there is a option to use open source model that we will be looking at when we start with the projects, like Llama 3 and Llama 3.1, 3.2. You can download and run on your machine, and they are free, so you don't need to pay anything for that. But again, the results will vary because it's a smaller model, so using the frontier model will give you a better results compared to open source models. Okay, so let's so that's about the API pricing and the context window. Let's move on to the next one. Let's look at one of the most important aspect of LLMs is prompting. So what is a prompt? The prompt is a specific input or task given to a language model to generate a desired output. So basically the queries that we provide to the model is called a prompt. So prompt, generally when we are asking questions, we don't even think about in a structured way what a prompt is, but better your prompts are, the better results you are going to get from the model, right? And there is a complete discipline behind prompting, which is called prompt engineering, and it used to be a very high paying job I think a few years back, but now it's not that much, but still it is very important uh, part to understand everybody who is working on generative AI using LLMs, how the prompts work. And prompts can be divided into four sections, and better you structure it this way, you are going to get a better output. So first part is obviously the instruction, what you want model to do. So it could be like summarize, translate, or answer this question, right? Clear cut instruction. Secondly is the context. So constraint, domain, tone, style. You can say that, okay, you should be funny, or you should be professional, or you constrain it. Like in soccer example, we said that you should be answering only question related to soccer. So you are giving a clear cut context to the model along with the instruction. Then third is the input data itself. Like so if you are asking model to summarize text, summarize below text in a humorous way, and here is the text, right? So text is the input data. Similarly, if you're asking model to describe an image, then you will provide an image. Or if you want answer to be derived from a document, then you provide a document. So input data. And output indicator, you provide how you want model to give you the output. Maybe you can say provide me output as a bulleted list, or provide me output as a markdown document, or in a JSON format, right? You might ask that your style should be use of generous use of emojis or something like that. So very clear cut instruction, provide context, input data obviously, and provide how you want to receive the output. So this is general guideline for a good prompt. Now there are various prompting techniques. One which we generally use and which is most common people use is called zero shot prompting. And it means that we are just asking our questions, we are not giving any extra information, any extra guidance, or any extra example to the model. So you just go and ask your question, and model based on its pre-existing knowledge is going to respond. It's free to respond the way it wants. You're not constraining the model at all. So this is called zero shot prompting. Another one is a few shot. So few shot can be divided into two categories. One is the one shot prompting. Another is many shot or few shot prompting. One shot means you are giving some kind of guidance. You are at least giving one example that how your output should be. And based on your provided example, model is going to provide you the output. So one shot and multi-shot are basically example of a few shot prompting. So let's quickly look at it with example, like how it works. So I'm in ChatGPT. You can use any other chat interface of your choice. So here is a example of zero shot prompting. So what I'm saying, classify the sentiment of following text as positive, negative, or neutral, and I am providing the text. So this is your instruction. All right, this is your data, and I am not providing any examples at all. So I left like, okay, so this is the text you just classify. So no examples at all. So sentiment is neutral. That's what it's saying. Okay. Now similar thing, if we go in make it one shot. So same context I have given, but I have provided an example here. The product is terrible and it is negative. So text, this is the my question. I think the vacation was okay, and what should be the output? So okay means is deriving that is neutral. I provided one example. I can provide many examples, so that will be the multi-shot prompting. Here, so here is one example negative, another example positive, and then this is my final query. So it came up with the negative, which is correct. So this is an example of prompting. So if you give more context and more guidance, more example to the model, that is multi-shot prompting is considered to be producing accurate results. But if your question is very simple question, very generic question that model can answer from your own knowledge base, and you're not too concerned about what kind of output you want model to generate, then you can simply use a zero shot prompting, which is pretty common the way we ask questions, right? Okay, so let's go back. Now there are two things I want to mention here. Is one is chain of thoughts, another is the react, and these are related with prompting. So what happened after this chat gpt euphoria started is the researchers found that okay, models are doing great and they are getting bigger and bigger, but they still found that the models are good at answering straightforward questions, but if the question is complex and which requires multi-step thinking, then they are not doing very good. And that's where the researchers came with concept of chain of thoughts, and they published a paper, I think it's in 2022, saying that okay, if the model is provided with instruction in a certain way, then it can reason through and it can solve more complex problems. And this was one of the first, probably the breakthrough when the agentic application were started to be built, and this is the basis for further research and the current state of the agentic applications that we see. So let's have a look at this paper and quickly see. Is this the one? Yeah. So this is the paper. The link I'll provide in the description. So what I want you to look at is this paper explores the ability of language model to generate coherent chain of thoughts, a series of short sentences that mimic the reasoning process a person might have. So just like human being, when we are given a problem and this is not a straightforward problem, then we generally break the problem and go step by step. So earlier models, when this paper was published, if you give a problem which involves multiple steps, then they were not very good at it answering. For example, this is the one of the examples they have given. This was the question, and this is one short prompting, and they have provided an answer. So this is straightforward. So Sean has 5 toys for Christmas. He got 2 toys from his mom and dad. How many toys he has? So based on this, they have straightforward provided the answer. And then they asked another question, which is more complicated than this. So there is this is not a direct question. So John takes care of 10 dogs. Each dog takes 0.5 hours a day to walk and take care of their business. How many hours a week does he spend taking care of dogs, right? So here they have provided data for one day and they're asking for it. So there is some kind of conversion is required. So it's a multi-step process, and the models then they were not able to answer this because they would go by this example straight away. So answer will be 10 multiplied by this, you get 50, right? But actual answer is 35. So what they did in the first question, in chain of thoughts, the only thing they changed is how you prompt the model. So instead of straight away giving the answer, what they did, they provided the steps. So they said, okay, in the first example, Sean started with 5 toys, then he got 2 from mom and dad, then that is 4 more toys, then you add 5 plus 4 equal to 9. So step by step breakup, right? And then they ask this question again. And this time, based on this one short example here, model knew that, oh, okay, so I have to reason through the problem, go step by step, and then solve rather than straight away giving the answer, right? And this time it came up with the right answer, 35. And this is what chain of thoughts is. Now, if thing is, this is not true anymore, because when this paper came along, the models then they were failing to answer such questions. Now, after this paper and subsequent research, most of this chain of thought things are now built into the model. So if you take this example and ask straight away to the model, it will be more likely that it will be able to answer your question. So let's try this. Okay, so this is standard prompting. I'm not giving chain of thoughts. So the answer we expect is 35. Okay, so I'm just pasting it, standard, and let's see. Now see, the answer is 35. Why? Because the chain of thoughts is already doing it. So it's breaking it. See, calculated per day and then per week. This is because this method or mechanism chain of thoughts is already nowadays built into the modern models. Okay, so this is chain of thoughts. Now another paper that came next year after chain of thoughts came is called React. Okay, so a bunch of researchers, they came along, and what they said is, okay, so models using chain of thoughts, the models are able to reason through the problem, and what they are proposing it, let's take it a step further. Not only reason through, but let the model decide what action to take in terms of solving a problem. Okay, and so it is based on chain of thoughts. One more step they have added is called ACT. So in React, RE means reasoning, which is chain of thoughts, and ACT means acting on the plan. So it knows what action it has to take. Okay, so this is the whole concept of React, and React is the basis for all the agentic applications nowadays, which is being built, where model takes a problem, it breaks it down, it prepares a plan, and based on the plan, it prepares the action, like what action I need to take. For example, if it is trying to do some kind of in medical field, it's trying to do some research, and it has been given a database database of the document to conduct the research. So it will break down the research question, the topic on which it is researching, and then it will prepare the plan. One step could be that, okay, I'm going to look at the database of the documents and find the information there, and then it's possible that it's not able to find everything from there. Then it might decide that next course of action will be, I'm going to search the net. So this decision making and planning and taking action is called React, and that's how the autonomous agents work. So again, here is the example they have given, like, and it's very clearly demonstrated. So probably you might want to go through these two papers, at least few pages initially, to get a feel of it, what exactly they are talking about. It's very easy to understand. So the first question, they asked is, aside from Apple Remote, what other device can control the program Apple Remote was originally designed to interact with? Now, this is not a straightforward question. So basically, they are saying Apple Remote was designed to control a device, and they are not giving the name of the device. And then they are asking what other device can control this program for which Apple Remote was designed. So it's a kind of indirect question. And then they have given examples. If you ask this question straight away without giving any chain of thoughts or any guidance to the model, kind of zero sort, then you will get answer they got is iPod, which is wrong. Then they said, okay, fine, let's do chain of thoughts. So this is the query they gave. Let's think step by step, and then the model is thinking step by step, and it came up with answer iPhone, iPad, and iPod Touch. This is also wrong. Okay. Then final is the React thing, where the model is thinking, reasoning, planning, and also acting. In this case, acting means is searching the internet. So internet search is the action. It knows when to search, and that's the crux of it. So now in React mode, it knows that it doesn't have all the knowledge that it requires to solve the problem, and that's why it act and it goes away and searches the net, and then it finds the correct answer. So this is the whole idea of React, which is based on chain of thoughts, which is based on basically a few short prompting. All right, so that's how they tie together. Okay, so let's go back. And so this is how React, reason only chain of thoughts, action only is act. But if you combine these two, an LLM in between, so what it's allowing LLM to do is not only reasoning and planning, but you are giving extra power or access to external world or the environment. You are giving it additional tools using which it can execute these plans and act and solve the problem. So this completes the whole loop, and that's what the React is. And this is the basis of all the agentic application, and it makes sense, right? So like as a human being, how do we solve a problem? We just do not start doing things, right? So if there is a problem in front of us, we first break it down, reason through, then we make a plan. Okay, so we understand the problem, and these are the steps we need to follow, and then we go and execute steps one by one. It is the same thing, same kind of ability has been provided to the model to do that. Okay, and that's what the React is. Okay, so I think we are done with the most of the theory part in first this video and the previous video in this series, and now I think we have a very solid understanding of what LLMs are, how they work, and how their messaging system work, what is an API. We have seen, we know the context window, we know the tokens, what a tokenizer is, then we know what prompting is, what different type of prompting, and COT, that is chain of thoughts, and React. So most of the fundamentals are in place now, and so we are ready for our next step, which will be straight away jumping and preparing for developing some cool applications. So first step will be to set up software and tools, and that will be the subject of the next video. So till then, bye, and I'll see you there.